Hi, I'm Orlov, and today is an interesting one. There's a lot of debate on what softwares to use with the Carvera machine, specifically CAM softwares, computer-aided manufacturing softwares. And there is no way for us to please everybody, but from the information that we've gathered on Kickstarter, we can make some recommendations. We are not in the CAD industry, the computer-aided design industry. We are in the machine manufacturing industry. We are not here to sell any softwares to you. Yes, we are developing a CAM software and we will move away from third-party CAM softwares when that is launched. But for now, here is just a guide for you to decide what software will be best suited for your ideas and applications. Now, some of the people in the community are beginners, so let's just take a step back. If you want to make your own projects, you have to find a software to create a 3D model or a 2D model of your project. This model is then imported into a CAM software, and this is where you generate your toolpaths. This toolpath in the form of a Gcode, which is just a bunch of text code, is then sent to the machine, and the machine then moves according to that code to cut a part from a piece of stock material. Now this video is going to focus on that part, the part between the designing and the manufacturing, the CAM software. And we have 3 recommendations that you can try, which is Fusion360, Vcarve and Kiri Moto. The structure of this video is first comparing and explaining each of these softwares and then using them to make this part. This is going to be quite a long video, so I've added the chapters below so you can scroll through the specific parts. Personally, I use Rhino 3D as my CAD software. I've been using it for years and this is what I'm most comfortable with. From there, I export either my model into a 2D DXF or a 3D STL or an IGS, and then import either to Fusion, Vcarve or Kiri Moto. And these are not the only CAM softwares that will work. There are many other softwares that will work perfectly fine. As long as the post-processor relates to the machine, then you'll be fine. The Carvera post-processor is very similar to a GRBL file post-processor. Now, what is a post-processor? The post-processor is the coding language that the CAM software exports the file into, so that the machine can read and understand the command codes. Some machines only understand some code, so the post-processor needs to be able to relate to the machine. On our website, you can download the post-processors for Fusion360 and for Vcarve. You can also download the tools that comes with the machine and the machine profiles. Most of the speeds and feeds are pre-set up in the softwares if you've downloaded the tool profiles. Feed rates and speeds are a massive topic, and every single material has a different recommended tooling parameter. Many are the same, but in my experience, there's a few things that I can recommend. First of all is to listen to your machine. If it's making too much noise or it's given a high-pitched sound or vibrating, then something is wrong. And it's mostly due to 2 things: tooling parameters, which is feed speeds, spindle speeds, ramp speeds, or the bits are damaged or old. Chip load is also important. That's the chips that's in the vacuum bin. If the dust is too fine, then either the spindle speed is too fast or the feed speed is too slow. If the chips are too thick, then it's the other way around. Document quality cuts. Check all the edges of your final products. A good CNC cut barely needs to be sanded. Save settings if you find something that works well. Every material has a different cutting recommendation. Some plastics has a lower melting point and might clog the bit. Some other materials might break or chip easier. Do research on the material that you're using. All the settings on the tooling profiles can be modified. We've supplied you with the basic and safe tooling parameters, but feel free to play around with these settings and modify to suit your needs. We will create a very detailed document of recommended feed rates and speeds at a later stage. You will see on the last page of the instruction manual, there is a very basic guideline on feed and speeds and different materials. Now this is the part that we'll be cutting. We will share the step file with you so you can test, try, change and see what software and settings works best for you. Now this part consists of a few elements. You can see it has an inside cut, it has an inside pocket operation. It'll have a tool change that has the engraving operation, a drilling operation, and then an outside cut. We'll also include some tabs on the inside just to keep the off-cut piece from flying, and then also some tabs on the outside to keep the part from changing its position. So I think it's a good test. It has a few different toolpaths, and I think it's a good example just to show what the softwares can do. Now I have to say that I'm not an expert in any of these softwares. I do understand the basics, but there are countless different milling operations that I cannot possibly go into this video. There are thousands of CAM software tutorials online that you can have a look at. This here is just a basic example of what steps to follow when you want to create your own toolpaths. So let's compare Fusion360, Vcarve and Kiri Moto. I think each of these softwares has a place for now. When the Carvera CAM comes out, that will be our main focus, but this software is still in development and will come out at a later stage. So let's start with Fusion. Fusion360 is a cloud-based 3D modeling, CAD and CAM software platform for professional product design and manufacturing. For $545 per year, it is a complete package, so if you're ready to invest and need a kind of all-in-one CAD and CAM solution, Fusion is the way to go. Fusion360 for personal use, also formerly known as hobbyist use, is free but has some limitations, and I think the biggest thing is that it doesn't support auto tool changes. But there is a little trick that I will show you how to combine your Gcode to support the tool change. If you are already familiar with the CAD software and only in the market for CAM software, we recommend either Vcarve or Kiri Moto. Vcarve Desktop Edition is designed for small CNC machines aimed at hobby and non-production environments. The software is more craft-based and focuses a bit more on relief milling. It does support all the functions that you need to create complex 2D and 3D parts, and also supports cutting in the 4th axis. I think that deserves its own video. The software has a design library that includes thousands of artworks and also gives you features to edit them and even create your own. So you can basically use the software to do design as well. The cost for Vcarve Desktop perpetual license, so it's just a once-off, is $349, and there is also a free trial available but with very limited features. Another thing to mention about Vcarve is that it only supports Windows, but you can run this through a Windows emulator if you're running a Mac machine. This is the software I'll be mostly using due to my experience with it. Your other option is Kiri Moto. It's a new player in the CNC game. It's a free open source browser-based application for CAM, 3D printing and laser output. There's no software to install, and all data and processing happens privately and local to the browser window. It supports all the milling functions that you would need, including tool changes. It also supports cutting in the 3rd axis and the 4th axis. At the moment, the 4th axis model consists of only indexed milling, which does each side separately, but I do believe that there will be many updates to the software, as the developer is very active on the development channels and offers great support and overall knowledge to the CAM community. I think this software is a great solution for beginners that is not quite ready to invest in a professional CAM package. And like I said, I'll be making the same part in all 3 softwares, so you can be the judge. So let's go in a bit more detail in each of these softwares and create the Gcode for this part. We'll start with Fusion. So first thing to do to set up the software is to go to this manufacturing tab. It opens in design. Just go to manufacturing tab, and then we're going to set up the tools, the machine and the post processors. So on our website, you can find under the software tab, you can find the Fusion download files. So just click on that link, that will automatically download. And then you go back to Fusion. Then first of all, we're going to do the tools. So we click on that. You can see mine is already set up here. I'll go under local, and then I'll just right click, say import libraries. Then you have the 3 libraries. You have the example tools, you have the PCB tools, and you have spare tools. Select all 3 of them and open, and then they will show up over here. Now you can see the way that we've laid this out. Every bit, as per your example guide booklet, is set up in its tool positions over here. You can see we already set up the different materials that you cut. So if you're using this bit, you can use a different, if you're cutting different materials, you can see it's already set up with the different feed rates, the lead-in rates, and the speeds. And then you have your PCB tools. if you bought the fabrication kit, everything is included there, and then also the spare tools, it's also included here. Next, we'll set up the machine library. So you go to My Machine, you can see mine is already set up here. So to import them here, you go to Local, right click Import in this open area, select from computer, find the 2 downloaded files that you've downloaded. There's a 3-axis and there's a 4-axis. Select them, open, and they will show up over here. This will give you all the settings and information about the machine on the 3-axis and also on the 4th axis. So there the machines are set up. Now let's do the post processes. Same thing, you click on Local, right click, Import, select the CPS file. This is the post processor for the Carvera. So just select that, import that, and that will show up over here. Now the software is set up. Now the software is set up and ready to go. So let's look at the example. This is the part that we'll be cutting. So just to give you an overview of this, the material thickness is the same size as the part thickness. So we won't be doing any facing operations on this part. I've split this into 2 sections because we're using 2 different bits. We're doing the engraving with the V-bit, and then we're doing the inside cut pockets, contours with the 1/8 inch 25mm end mill. So I've split this up into 2 sections. You can see here tool 1 and tool 2. Now what we've got here is a 2D pocket. That's just a basic 2D pocket. You get that over here. Then you have your adaptive milling. Not really a big difference in these two. The adaptive milling is a little bit more intuitive when it comes to complex parts. This part doesn't really show the effectiveness of the adaptive milling, but it does show you the difference between a pocket and the adaptive clearing. We'll also do a drilling toolpath, and then we'll do a contour toolpath. We'll add some tabs as well, like you can see there, and then that will be the first cut, and then the second cut will be the engraving part, which will be the letter set here. So we will export that as a single file, and then we'll export the second tool as a second file, and then combine them in the text format afterwards. Reason for doing this is when you're using the free version for Fusion360, it doesn't support exporting tool changes. So we'll just do that afterwards. Okay, so let's get started. So let's just delete that and delete that. Okay, now our part is set up here. This is now just the imported part. I've created this part in a different software. This is an IGES file that I've imported from a different software. You can also create this model in Fusion. Then you don't have to export anything. Then you go straight from design into manufacturing. So first of all, what we'll do is we'll set up the stock. So we'll go here to set up the material. We'll first select the machine. We just uploaded this. So we'll select the 3-axis Machinable Carvera machine. That's selected. We'll be doing a milling job. And then we're going to select the origin of this job. Now, at the moment, you see it's sitting in the middle. Now, this is the XY origin of your toolpath. So basically, you need to this needs to be relative to the anchor point 1. So in this case, if you're looking at it from the top, this will be the XY location of anchor point 1. But this is not going to work because then it's going to cut over anchor point 1. So we'll change the XY location to this box point. And then we'll create some clearance in the stock tab now. Then you can see the position is correct in relativeness to the machine bed. So we will select, now this software needs to know what it's cutting. So we'll just select the model. If you select here, that selects the full model. And then we're going to say, okay. Now we're not done yet. I just want to have a look and to see if that's working. That looks quite good. So we go back to the edit function. Now we're going to set up the stock. Now because the height is exactly the same as the part, we do not have a top offset. So the top offset is going to be 0. Side offset is surrounded by the part. So we know that the bit that we're cutting this with is 3.175 millimeters thick. So anything more than that should suffice, but I recommend going to about 10 millimeters. Going to about 10 millimeters, just to make sure that if you mount this in anchor point 1, there's a screw that's going to sit over here and there's a screw going to sit over here. So just to create a little bit clearance, this will just make sure that you don't interrupt any of the clamps. So this then gives you the stock dimensions. If you work from the design first, then looking at the stock, then you'll have to look at these dimensions to make sure this is the size of the stock that you put in there. And the stock height of the material is 10 millimeters, so no problems there. You can also move this part, but we're not going to do that. We like our part being centered in the stock. So this is set up already. You can change the dimensions here if you need to, but I don't really see a need to do that in this example. Then the last setting here is just the program number. This is the naming convention of your toolpath, so we're not going to mess around with that. Maybe we can just say here test 1. Okay, so now our material is set up. Now we need to start looking at the toolpaths. So first thing we'll do to set up this part is to create our 2D pocket. Now you have two options here, the adaptive clearing and the 2D pocket, very similar. We're going to do both of them just to show you the differences between them. So we're going to select 2D pocket. We're going to select our tool, which will be the 25 millimeter end mill. So we select that. All these feed rates and speeds is already set up. You just have to select here what you're cutting. We're cutting softwood, so the settings will be updated if you're using the tools that we've included. Next part is the geometry. Now we will do the selected pockets here. Now there's lots of differences. So if you do a pocket selection, if I select this face, for example, it's only going to cut the inside of that face. So this is the incorrect selection. So take that away. If you're doing a pocket, you want to select the contour, which is that one. So then it's going to cut that whole section on the inside. We are not doing any rest machining because our bits is all the correct sizes. And stock contours, we won't be using that for this example. Heights, here is where you modify your clearance heights. This is if you have any obstructions and the part needs to move up and around something, but we don't have any obstructions, so we're not going to mess around with the clearance height and the retract height and the feed height. The top height, this is where your cut starts. So this will be at the top of the material. So it says stock top, so that's correct. The bottom height, that's the bottom of your cut's height. So we're only cutting to that plane over there. So and that is from the selected contours. And if you go back, you can see that is the contour that we selected. So selected contours is correct. Then we'll do passes. Tolerances, you can play around with this if you have parts fitting together. For this example, we don't have to look at that. And then there's lots of different settings. We are not going to leave any stock. We are finishing this part to the, you can select there. If you're cutting through a part but you want to leave a piece of material at the bottom, you can just select the stock to leave and you can say how much material you still want to hold the piece down, and then you have to cut it out later. We are going to use multiple depths. Now we're cutting foam, we're cutting the tooling board, so I have noticed that 3 millimeter is a good depth. The machine handles that quite well with the speeds that's already set up here in the tools. So I'll use 3 millimeter here. Here the linking is also a lot of settings you can play around with. I can't go into each of them. It's just basic movement settings that we're not going to focus on right now. So if we're happy with all of those, we say okay, and then it'll create the toolpath. Now just to check this, you can go to simulate. I'll slow it down just slightly. Then you can see what the bit will do. So it will cut into the material like that, and then it will start doing your passes. Now this is typical of a 2D cut. It just spirals out in the shape of the inside cut of the border. So that seems quite well, and you can just look if it's cutting right to that surface. If that blue line is touching that face, then you know it's cutting all the way to there. And that's our first toolpath. Second toolpath will be cutting through this material here on the inside. So what we'll do here, we can also use a 2D pocket for this, but I'm going to use adaptive clearing just to show you the way that the bit moves when you're doing adaptive clearing. So we're going to select our bit. This will be the same bit. Tool number 1. Settings is already updated. We're going to just select our preset mode. Then we're going to go to geometry. Now I'm going to select the bottom contour here. And we don't need any rest machining. We're going to go to height. Now we're just going to check the top height. It's seeing it, it's going to start cutting at the top of this height now. But I need the machine to only start on this face. And then the bottom height of your cut is the selected contour, which was the bottom one. So if we select that height correctly, we go to passes. Yes, we are doing multiple depths. Like I said, we're going 3 millimeter depths per pass. We do not need any stock to leave because we want to cut through the part, and then we don't have to mess around with any linking settings. We hit OK. Let's see what this does. Now that to me looks pretty good. Let's just simulate this. So it's showing the bottom one. So it's just passing through the material with the spiral, and then it's going to do our first pass. It's going to go up, do second pass, and then cut through the material. If it's not cutting through the material, you'll still see a surface there, but it seems like it does, and that's what we want. So we'll exit simulation here. So just to show you, if I go back to height, and I said offset 2 millimeter, it's not cutting through the material now. You see? So I'm going to go back here, edit, height, now offset here, select, and I'll see it's cutting through the material again. Okay, so that's the adaptive clearing. Next thing that we'll do is to program this hole. Now this is a drill. Now I will select our tool once again. Where is our... Oh, the tool's already selected. So feeds and speeds is already set up. Geometry will be this hole. Now I made this hole 5 millimeters with purpose, just to show you that when you do a drilling pass, it doesn't see the hole as a pocket. It sees the axis of the hole. So if you're using a 3.175 bit like we're using, this diameter of this hole is not going to be 5 millimeter. It's going to be 3.175 because we're only drilling that hole. It's only looking at the axis. It's not looking at the sides of the face. So if you selected faces, that's the face that I've selected. So it picks the center of the hole and it drills right through the hole. If you need to make this a 5 millimeter hole, you'll use a different setting, which would be bore. And you select this, then you can see what the tool will do is actually spiral down to create the thicker hole. But for this case, we're just going to be doing a drilling. So let's cancel this. Do drilling, select that hole. All faces is selected. Heights is already, the bottom height is the whole bottom, the top height is the whole top. So it's, the software is smart enough to know that that's a hole, that's the top of the hole, and that's the bottom of the hole. So it's going to cut right through, no problems there. Cycle, this is also the type of drilling that you need if you're going into different materials with different bits. There's a whole lot of different ones here that we don't have to look at for this example. We hit OK. And now we have a hole. Boop. Quick and easy drilled hole. Alright, the next thing that we'll do is a contour cut. 2D contour. The bit's already selected. Where are these things going? Let's select this bit again. There we go. Okay. So everything here is set up. Our preset is softwood. Geometry. This will be then the outside border of your part. Here is where you add your tabs. So this is also thing. This is here you can change all the settings, the size of the tabs, the distance of the tabs from each other. Like I'm looking at it right now. That's not really. Let's do segment. Then it's evenly spread out tabs. That looks pretty good to me. Heights. It will start at the stock top, start cutting at the top of the stock, and then it's going to stop cutting bottom height at the selected contour, which is the bottom one that we selected. Passes, we'll do multiple depths. We're going 3mm per pass. Happy there. We do not need stock to leave because we have the tabs. And then linking, we don't have to mess around with any settings over there. Hit OK. And let's have a look here. So here you can see now you have 1, 2, 3, 4 passes. And then the bottom one has got the tabs also included. That moves over that tabs just to hold the part in place. Okay, so let's have a look at this whole thing. Full cut. It's first going to start milling out the top. This is the 2D contour cut. Then it's going to go down and do the adaptive clearing. Then it's going to drill the hole, and then it's going to go around and do another pass, and then you can see the tabs are cutting there as well. That seems pretty good to me. Our first setup is complete. So next thing that we'll do is we'll create a new setup. The stock will set up from preceding setup. So it'll be the same XY location and everything from the previous setup. We're doing milling. The machine is already set up. Stock. Let's just select this box point. We know that that's the same as the previous one because the stock is the same size. We're not going to move the position because it's the same. The part is in the exact same position as the previous one. Don't have to change these codes. Just hit OK. No model selected. Okay. Here the model is selected. Okay. Now what we'll do here is we'll go engrave. Then we're going to select the top contours of these letters. Sometimes a bit tricky to select them. We need a tool, and we're going to be using the V bit. The 0.2 tip engraving bit. We select that. We are cutting softwood. Geometry has been selected. The heights. Now this is another thing to keep into considerations. So the top height is the selected contour because you selected the top contour of this letter set. The bottom height will be from the top height. So this is the depth of the cut actually, the bottom of your cut depth. I'm just gonna say, yeah, it's already on -5. Let's stick to that. Then we're gonna go do passes. We're not doing multiple passes, multiple depths, because we're just gonna do one engrave depth. So we're not gonna click that. We're not doing linking. Let's just hit OK. And let's see what this does. Let's see what this does. Okay, something's not right here. Let's just figure this out. You see it's going way too deep over here because this is where the part is a lot thicker. So let's just go back here. We go to edit. Retracted height is the stop minus. Oh, it says -5. We're going 0.5. And then if we go here to simulate, you can see that cuts at the right depth. It's a little bit deeper than our model. But I think that's going to be okay. Yeah, I think that's good. Exit simulation. Now we got this. Let's just rename this tool 2. And that's got the engraving tool, and then there's your other tool path. So let's export these. So we go to tool 1, we go post process. Now the machine we have already loaded, that's already loaded onto the tools, and the post processor is the one that we've already uploaded. So that's the one that we're using. Then here you can just change your name. This will be main cut, and I'll just do that on the desktop. Here you have the option of splitting by tool, but I'm just saying no splitting because I have to export them separately anyway, so I'll combine them afterwards. So I'll just hit post, and then that has been successfully exported. Then we go to the second file. We'll call this engrave. Select that. Then these two files will be exported to the desktop. So we have main cut and we have engrave. Now, if we open these two files, you can see this is the full code. Let me make this smaller. This is the full code for the main cut. So I'll go to the engraving. I'll Control A. So select all, copy that. Go to the main cut, go here, space, insert this copy file, and then I'll go file, save as, main cut, include engrave, and I'll save that to the desktop. And then you have your main engrave file that we can now import into our controller software with the automatic tool change. Okay, so let's have a look at Vcarve. First thing that you'll do is you'll create a new file, and then on our website you've already downloaded the software. You go to the software tab and you go down, and then here you can download the Vcarve profiles. So once that's downloaded, you go back to the software and we'll set up our machine. So we'll add machine, sorry, wrong one, machine configuration. Now here you can see I already set this up. It's just typing in the details of the machine and then installing the post processes that is linked to that machine. So to install the post processes, you go to this little plus sign over here, and then you'll find this little folder down here. Then you go to your downloads folder, to the Vcarve desktop, and then you see there's 3 downloaded files. There's the Carvera laser, that's the wrap X2A ATC, which is the 4th axis, and then you have the Carvera ATC, or the tool change. So you select all 3 of those, and then you just click open, and then it'll import over here. And then we'll just close, and then after you've typed that in, you've got your machine set up, just hit OK, and then we can start setting up our job. So I know what the stock size is that I'm going to be using. It's 150 millimeters by 100 by 10 millimeters thick. The same as the previous part. It's the same thickness as the material, so we won't have to do a facing operation. To do a facing operation, we'll just have to draw another square over the part. But let me just show you how to do that. So let's just do the job setup. We're going to do a single-sided setup. If you're flipping your part, you can click on double-sided. For this particular part, we don't have to do that. And then for rotary, this is also where you set up your 4th axis. So what happens in the 4th axis is it changes the Y value to an A value. So it's basically the Y is replaced with an A value, which is then converted into a rotation. Instead of the Y moving, then you're just rotating the part. So this is where you'll set up your 4th axis jobs. I think that will be a separate video. So for this show, we're going to go single-sided. I know that my material is 150 millimeters wide, 100 millimeters high on Y, and then 10 millimeters thick. The Z0 position is on the material surface. There you can see the little red mark. This is where your Z probe will mark the material. And then the XY datum position is also in the bottom left hand side corner, where anchor point 1 is situated. Here you can change the resolution to see how just the rendering of your part, and then you can change some material settings here. We're not going to mess around with that now. So we'll hit open. Now we will import our file as a DXF. So it's a little bit different than the other formats. I'll just get this part, place this onto the material. Now you can see I've imported this part with a borderline. This is just to create a little bit of an offset on the part itself. So I don't have to set any offsets on the machine. If the XY location was in the corner of this part and I didn't import this external boundary, then I would have, in the controller software, just have to set an offset to create the space that we have here for the bit to run and for the bit to run over here. We also know that this is going to sit in anchor point 1, and there's going to be a little screw over here, and there's going to be another screw over there. So once that's placed into position, you can see there's lots of settings here you can play around with. You can modify the 2D lines, you can change it, you can draw some more lines in here if you want to draw some mounting holes, things like that. You can use all these edit object features, offset, layout, transform. So this is all the operations you can use to modify your DXF or your 2D of your part. And then over here you can mess around a little bit with the modeling, and then included in the software is thousands of artworks and things that you can use to create your own pieces. Like I said, there is quite a lot of them, and look at it, it's still loading. There's thousands of things you can play around with to create your own artworks. You can play with the layers as well, but for this it's going to be very simple. It's a very basic example of this. So we go back to drawing. Everything is set up here. We know that the white part is the material, and now we're going to start setting up the toolpaths. Before we start with the toolpaths, let's just set up our tool database. To do this, you just go to the tool database tab, and then you just import a tool database. Then you go to downloads, and then find the downloaded tools and just select Carvera tools, and then open this, and this will update automatically and then give you the Carvera tools breakdown. It's similar as the one we have for Fusion360. So the example tools are set up here as it is placed for the examples. So you got your 25mm flute, endmill, and all the other bits that you'll use for creating your examples, and in their position. So this will be tool number 1, tool number 2, tool number 4, tool number 6, you'll see. And then all the spare tools are also in here, the engraving tools and the drill tools. And then you have also your PCB tools if you bought the expansion PCB fabrication pack. So here you can choose all, and you can see all the speeds, spindle speeds, feed rates is already set up. But for this example, you set up the tools when doing the profile toolpath. So first thing to do when setting up the toolpaths is just to make sure that the material is set up correctly. So I'll just have a look here. We already set this up previously on this side, but just to make sure that everything is good and that model positioning is correct, we'll just go through all of these. So we know the thickness is 10mm, the XY datum point is on the right hand side bottom, the Z0 is on the material surface. Here you change where your model sits in your material. So if you have a part that is 8mm thick and the material is 10mm thick, then the gap above the model is going to be 2. So the part is going to sit over here, and then that will mill off the top material just to get the correct height of your part. But for this example, we have the part is 10mm and the material is 10mm. So this stays 0. The rapid gaps above the material, 5mm is enough clearance and 2mm plunge clearance is enough. And then here you can also set an offset. You can do offsets in the CAD software, you can do offsets in the CAM software, you can also do offsets in the Carvera software. So there's lots of places to play around with offsets. I don't like to play around with offsets, that's why I like to put in this borderline. But this is just my preference. Some people will import only the part, and then the XY location would be over here, or manually you move this part manually to an offset position, but then still export the XY point as this point. So there's lots of different ways to handle offsets. For me, I like to import it with a borderline, which is the offset, so I know, and then I don't touch this, I don't program anything on this line, I just know it's only there to create an offset of my part, to create space for the bits and the clampings. So everything here looks okay to me. We're gonna hit OK, and then we're gonna start with our first toolpath. Now the general rule that I use is to do the inside cuts first. So the first thing that we'll do is we'll do this pocket. Now, when working in a 2D environment like this, you have to know the heights. You have to know the heights that you are actually programming these toolpaths at. So I know my part is 10mm thick, and I know this pocket is 5mm deep. This is because I've modeled this up and I know the heights and the specs surrounding it. So let's do this pocket first. This will be, we're going to start at 0. So the D is the top of the material. So that will basically be Z0. And our cutting depth is going to be 5mm. So that line is going to start at the top of the material and then cut 5mm down. Here we'll select our bit. So I will just use the 3.175, the 1/8" bit, to use as the cut of basically all these parts. I'll use the V engraving bit for the letter set. That's selected. We'll just have a look at the passes. I know that with this bit and this material, which is the tooling board, I can cut at about 3mm. So if we lower this passes to, if it's 1 pass, it's going to be 5mm. If it's 2 passes, it's going to be 2.5mm per pass. So that seems good to me. We're gonna hit OK. And then here you can change the cut direction. This is the direction of your toolpath according to the rotation of the spindle. So in my experience, I've noticed that when you do an inside cut, it's better to climb, but it's all dependent on the material and also dependent on your bits, and it's also depending on your rates as well. So personal preference, I climb inside cut, climb outside cut conventional. But this might differ for people from person to person, and also differs from material to material. So we're gonna call this pocket, inside pocket, if I can spell. And we'll calculate this. So let's see what this does. And let's go here and we simulate this toolpath. Just going to slow the speed down. The resolution of the cuts in the software is not great. So this automatically gives you a second pass on the inside pocket. The reason for this is that I've selected two tools in the previous tab. This is useful with Auto Tool Changer. If your part has small inside corners, then it will change and do a finishing pass with a different bit. You can see it's a little bit more offset the last cut. So that's going to just give you a final pass surrounding it. So let's leave it that way. We're going to go back to close. And then we're going to go back to 2D. Now we know that's sorted. Now we're going to cut this inside cut, which is this part over here. So these lines also show you the direction of your cuts. So we're going to select this line. Now next thing that we'll do is we are going to do an inside cut of this part. So there's lots of different methods of cutting. I recommend just exploring all these methods. There's so many different ways of doing inside cuts and outside cuts and lines and on the line. So there's lots of different methods. I can't possibly go through all of them. But for this, I'm going to do an inside cut. So I'll just do a 2D profile toolpath. The start depth is now going to be on 5 millimeters. So, and then the cut depth of that is going to be 5.1 millimeters. So it's 5.1 millimeters. Let's call it 0.05. And we have selected, we've got the right tool selected. This is going to be an inside cut, so it's going to cut on the inside of that line. These last separate parts. We are going to add a tab here. Just because I don't want this off-cut part on the inside here to go flying. So we'll add the tabs to that. We're going to say here inside cut. Spell once again, inside cut. Let's calculate that. It's going to say that it will cut through the material, which is okay. We do want it to cut through the material because we have added tabs, and this will still, the tabs will still hold the off-cut part into position. Hit OK. And let's slow this down a little bit. Preview all toolpaths. Just a second, that looks good. That looks good. That looks good to me. So this is an off-cut piece. That will just be held into position there. Okay, next thing, happy days. Next thing that we'll do is we will cut this hole. If this is a drilling toolpath, it's going to see the axis of the tool. If you're doing, this hole's diameter is 5 millimeters. So if you're going to do a drilling toolpath, cut depth is going to be 10.05. Tool is already selected. Pick drilling is how it retracts, like drill retracts, drill retracts. We don't need this because the material is fine. We'll just do a one pass drill, one drill. And then we'll say calculate. It's going to say cut the material, not a problem. And there's one drilled hole. If you want this hole to be 5 millimeters, then you'll just use an inside cut profile toolpath to create a spiraling down toolpath that creates the 5mm hole. So that's done. 2D, the last thing that we'll do will be the letter set. So let's just select all these letters. Go to toolpath and we'll go to Vcarve engraving toolpath. Now the start depth is going to be at 0. We're going to create a flat depth of 0.5. We will select the correct bit here, which will be this one. This is the tool number 2. Select this. The feed speeds and rate is already set up. We're cutting into foam. You can up this feed rate a little bit when you're cutting the tooling board. Plunge rate a little bit. The rest of it seems fine. I'm not worried. I'm not going to change anything here at the moment. So I'll just hit select. We don't have to use any clearance tools. Let's just calculate this and see what happens here. Now I like the way that this is actually cutting these letters, because it's cutting the whole inside part of this letter. So it's doing an inside cut and then cutting to that borderline. So if we hit this, let's see what this does. Carve error. That looks really good to me. So that's the engraving toolpath. Let's hit close here, and then we're going to do our final cut, which is going to be the outside cut. We're also going to add some tabs to the outside cut. So we're going to go to profile toolpath. Now this is going to be, the start depth is on 0 and the cutting depth will be 10.05. Then we're going to just check the passes. If we do 4 passes, the depth will be 2.513, which is less than 3, so that would be okay. Back to the toolpath here. This is going to be an outside cut, conventional, separate pass. We are going to add tabs to this, so let's just manually add some tabs. 1, 2, 3, 4, and we close. We are going to call this the outside cut. Once again, I can't spell. And calculate. It's going to cut through the material by 0.5 mm, which is okay. We're going to hit OK, and then let's do a preview of that. 2, 3, 4 passes, and the tabs are included. And there we have our part. Now we're going to select all the toolpath. We're going to say, just close this. Then you go to save toolpath. It's got inside cut, and then it's got the engraving, so it changes to tool 2 there, and then you have your outside cut right there. And we are using the 3-axis, so we will use the Carvera ATC post processor. The machine is the Carvera machine, and we'll save toolpaths. We'll call this Vcarve tool change. Sample block. Just save this to desktop. And there you have your completed toolpath. So let's have a look at Moto. This is a browser-based software, so there's no software you have to install. You just run this straight off your browser through CreateSpace. Now, first of all, the layout of this, definitely go check out the maker of this software's video. There's a definitive guide that shows you exactly what the purpose is of all the tabs. I cannot go through all of them. So I'm just going to show you the basics of how to do pockets and some contour cutting, and then cut the part on the Carvera machine. So at the top here you have your device setup. So here you can see you can do 3D printing here as well, do CNC and laser engraving as well. So we're just going to pick CNC for now, and then you'll see the machine is already in the drop down list here, so it's already imported here. So then I'll just select that device. Here you can change some more settings, but I'll just save that for now. And then the rest of this is also links to the same tab here. On the right you can set up your machine preferences, you can upload the files, import recent files with the viewing strategies, animations, previews, visual representation, and some more tools here. And on the right you've got some modifiers here. This works in conjunction with all the tool paths. The milling operations is at the bottom here, so here is where you add all the tool paths. There's a few different ones, I can't go through all of them. I'll just use the ones that's needed to cut the part that we will be programming. So let's first start with importing our file. I'm just going to say import, and this is an STL file that I'll be importing, and then this is the part that we will be cutting. Now first of all we're going to set up the stock, and I know that the height of my stock is 10mm. I know the model is also 10mm, so we don't have to do any facing operations. The width of my stock is, it depends also which one you are selecting here. If you're doing an offset and I want a 10mm clearance at the top and 10mm clearance on the depth and the width, and I enable this, then you'll still see this is still a bit thick, so the height will have 0 offset. So then you see there's a stock. I'll add a bit more here, so it'll 10 on both sides, 10 on both sides. So there's our stock setup. Then here you can add some tabs, add some limits of the x-axis. So I'll put in some more settings here. So the first operation that we'll create will be a pocket, just to pocket the inside of this area. So we'll select over here pocket. You see there's lots of different ones. Tracing is more like an engraving function. Drilling is just drilling holes. If you're doing a double-sided, you can flip the part. You can register some drill holes, put the laser on and off. So let's start by creating our first pocket. So the tools are over here. This is where you pick the tools. You have to set up your tools here. These three comes with the software, or is included in the software. From there you'll make your own bits. So I'll be using the 8" and the V bit for the engraving of the letters. So to add a new one, you just click on this plus sign over here, and then you add in your dimensions of your new bit and just save that, and then that's done. And that will talk to this little drop down over here. So we'll be using the 1/8 of an inch end mill just to do the pocket of that. So settings is set up here. The step over, we know it's 3.175, so 1.5 is sufficient step over. Feed rate I'm going to keep at 500. Plunge rate we're going to keep at 200. We'll deselect contour and outline, and then just click on the plus sign over here. Select the face that we want to cut. Exit. Hit OK. Press S, and then it actually shows you, the white line shows you where your tool will run, and that is the pocket. So you can also simulate this by pressing on animate. So we'll just see what's going to happen here. So it just trims out and cuts that inside part. That is what we want. Next thing that we'll do is we'll create the pocket engraving for this Carvera letters. So we'll do the same thing, pocket, and then we'll select the V-bit and then the step over. Because the point of the V-bit is 0.2, you have to go less than that. So I'm going to do the step over 0.1, and then the step down is going to fall away because we are doing an engraving. So you're going to select the contour and then we're going to engrave that. Hit OK, plus sign, and then you select the faces that you want to engrave. Check that, and then let's press S and just see what happens over here. Yes, so now you see that'll cut on the outline of this letters, double line there. This is the C and the E is a thicker letter, and then the R, A over there. So we'll press A again. So we've got our first pocket with our 1/8 of an inch bit. Then it will do the engraving with the V bit. That's tool number 2. So the next thing that we'll do is to cut out the rest of the part. We'll do that by using the function outline. So we'll select the right bit for that. Spindle RPM at 3000. The step down is at 3 mm per pass. Feed rate I'll keep at 500, and the plunge rate I'll keep at 250. Now if you have any parts fitting together with inside corners, sharp corners, you can add the dog bones, you can add these features over here. If you only want to cut the inside of the part, you switch this on. If you want to mud the part cutting through, you select this. If you want to do a wider cutout of the part, you can do that here. And if you want to clear the top, means facing the top, you do that over here. So we are happy with that. We press S, and then it read the inside of this part. And it's also cutting out the outside of this part. One thing that we'll have to add to this part is some tabs. The width of our tabs, let's call this 5 mm. The height of them, let's make them a little bit bigger than 1. And the depth of them will be 3.175, which is the thickness of the bit. So we'll add the tabs here. We'll just go on this plus sign. We'll add a tab over here, over here, over here, and over here. And then let's press S again. Now you see this has been updated. It's also reading the inside of this hole, so it's spiraling down and doing every pass, spiraling, pass, spiraling. So let's run the simulation on this, animate this. It's going to cut that top part, the pocket. It's going to do the engraving. And then it's going to do the outside cut. Carry on with the inside passes. Cut straight through the part. Now you can also see our tabs has been left out, so our part will still be in position when we're done cutting it. Let's add some more tabs on the inside here. I'm going to add a tab here and here. Here, just to secure the off-cut material we're going to have on the inside of this part. And then let's just animate this again. Here you can change the speed of your animation as well. I also see, so the off-cut part that we're going to be cutting is going to stay in the position on the inside, so we can break that out afterwards. And there you have your complete modeled toolbox part. For this example, we're only using the 2D milling, but if you're doing some roughing, outlining, contour cuts, you can do some really detailed 3D parts, but we'll do a video of that at a later stage. Last thing is to export this part. Now to do that, you just go to the start menu here, and you go to export, and then all the combined tool parts will be exported as a single file. So you just go here, download, and it will automatically download the NC file ready to import into your Carvera controller software. And there you go. Just a brief look at the 3 softwares. I know this was a very basic overview, and if you want to go into more detail, I do recommend checking out some definitive guides and tutorials on the specific software. But like I said, this is a guideline to the order of operations when you want to create your own projects. I'll be making some more videos in the future on relief milling, 4th axis milling, and also how to program the laser cutter, and also the software that goes along with that. If you want me to focus on anything in particular, let me know down in the comments below. Links to our website and social media accounts in the video description, and like and subscribe to see some more of these videos. Cheers.